ever Introduction to Climate Change class. My name is Lisette Ochoa, and I'm a recycling specialist here at the Riverside County Department of Waste Resources. I'm very excited to discuss climate change, and I hope everyone can leave the class today feeling more climate action ready. Before we get started, I do want to mention we will have a brief check-in point during the class, as well as 15 minutes at the end to address any questions. So please feel free to drop those in the chat as we move along. All questions are welcomed. Riverside County is part of the ancient homeland and traditional territory of 11 tribal nations. We pay respect to all their ancestors and descendants, past, present, and future, and their continuing presence in the homeland. Today, this gathering place is home to several indigenous peoples from all over the world. We recognize, honor, and respect these nations as the traditional stewards of the land, water, and air. In addition to landfill management, the Department of Waste Resources offers free educational classes focused on sustainability and waste diversion. Please visit our website at rcwaste.org for more details. So once again, a little bit about me. My name is Lisette. I recently graduated from UC Riverside, where I studied sustainability and environmental sciences. My background and interests include environmental justice, climate and community resilience, and of course, waste reduction. And fun fact about me, I've been vegetarian for almost 6 years.
Wow.
Here's our agenda for the class today. We'll be kicking off with some important terms and definitions in the climate chatter section. Next, we'll dive into causes of climate change. Then we'll delve into climate change impacts on the environment and society through indicators. Lastly, we'll close with some actionable items we can all take on to address climate change. So let's attack some of the most common terms used in climate science. Most of these definitions, along with other materials throughout this class, are derived from the Environmental Protection Agency, EPA, the National Aeronautics and Space Administration, NASA, and the Intergovernmental Panel on Climate Change, IPCC, which is the United Nations body that provides regular assessments of the scientific basis of climate change, its impacts and future risks, and options for adaptation and mitigation. Anthropogenic is made by humans or resulting from human activities. The word anthropogenic is usually used in the context of emissions resulting from human activities. The atmosphere is the gaseous envelope surrounding the Earth, 78% nitrogen and 20% oxygen and other trace gases approximately. The atmosphere is like a jacket or blanket that surrounds our planet. It keeps us warm, gives us oxygen to breathe, and is where weather occurs. Climate is the average pattern of weather conditions over a long period of time for a large area. It's important to make the distinction between climate and weather. Weather refers to the conditions over a short, particular time and can change within minutes or hours. Climate, on the other hand, is how the atmosphere behaves over a long period of time and space. Radiation is the energy transfer in the form of electromagnetic waves or particles that release energy when absorbed by an object. Infrared or long-wave radiation is emitted by the Earth, in contrast, the Sun emits short-wave or solar radiation. Sorry if this sounds confusing, we'll see a visual of this process unfolding in a bit, but it's important to know that radiation comes in many forms and is all around us all the time. The greenhouse effect is the trapping and buildup of heat in the atmosphere near the Earth's surface. The greenhouse effect is one of the many things that make the Earth habitable. A greenhouse gas is any gas that absorbs infrared radiation, otherwise known as heat, in the atmosphere. We'll focus on some key greenhouse gases shortly. Global warming refers to the recent and ongoing global average increase in temperature near the Earth's surface. The Earth has warmed and cooled throughout its long history from natural causes, which are still in play today. However, anthropogenic activities have resulted in an increase in greenhouse gases, therefore enhancing the greenhouse effect and overall rising the temperature of the Earth. The IPCC estimates the Earth has warmed 1.96 degrees Fahrenheit since pre-industrial times and expects a global average temperature rise of 2.7 degrees Fahrenheit between 2030 and 2052. Please note, global warming is just one aspect of climate change. Fossil fuels are coal, crude oil, and natural gas, which are derived from ancient plants and animals over millions of years old. Fossil fuels are burned and or refined to provide electricity, heat, and transportation. Let's focus on each of these for a bit. Coal, the most abundant fossil fuel, is a black or brown sedimentary deposit extracted through underground or strip mining. Coal is primarily used as a fuel to generate electric power in the United States. The heat produced by the combustion of coal is used to convert water into high-pressure steam, which drives a turbine and produces electricity. Crude oil exists in a gaseous form in underground pools or reservoirs. Crude oil is extracted by drilling a hole into the earth and is then transported to oil refineries to be transformed into usable fuels, most notably gasoline and diesel, as well as petroleum products. Lastly, natural gas is also found in underground deposits, sometimes along with crude oil. Natural gas and oil wells can be drilled vertically and horizontally into natural gas bearing formations. One method is hydraulic fracking. Most natural gas in the United States is used for heating and generating electricity. All fossil fuels are non renewable energy sources. Once these resources are used up, they cannot be replenished. Aerosols are small particles or liquid droplets in the atmosphere that can absorb or reflect sunlight. Despite their small size relative to fine sand and human hair, aerosols can have a huge impact on our climate and health. The common effects of aerosols depend on their chemical composition, color, size, shape, and where they are emitted. Aerosols may come from anthropogenic activities as well as natural sources such as volcanoes. Lastly, ecological footprint is a human's impact on the planet, resource consumption, waste generation, etc., measured in demand on and supply of nature. Simply put, our ecological footprint is our contribution to climate change. Please note climate change is an ongoing global crisis that has many facets, and thus some terms may not have been included since we're just covering basics, but I encourage everyone to branch out and complete additional research. So let's revisit this process of the greenhouse effect. In a nutshell, the sunlight reaches the Earth. Some of this energy is reflected back into space, but some is absorbed and re-radiated as heat. Greenhouse gases trap this heat and make the planet warmer. Although this process is naturally occurring, anthropogenic activities have led to an increase in greenhouse gases in the atmosphere over the last 150 years. With our climate change basics covered, we can finally address the question at hand. What is climate change? Climate change refers to any significant change in the measures of climate lasting for an extended period of time. In other words, climate change includes major changes in temperature, precipitation, or wind patterns, among others that occur over several decades or longer. The Earth's climate is always changing, but natural causes alone cannot explain recent phenomena. Anthropogenic activities, such as the burning of fossil fuels, are contributing to the global crisis. According to the IPCC's latest sixth assessment report, Impacts, Adaptation, and Vulnerability by Working Group 2, human-induced climate change has caused widespread adverse impacts and related losses and damages to nature and people beyond natural climate variability. Next slide, please. But before we dive into those impacts, let's look at the scientific causes of climate change. We'll be discussing natural processes, anthropogenic activities, and perhaps the most alarming, climate feedback loops. Please note these are just a few examples. I highly encourage you all to conduct further research. Changes in the Earth's orbit and its axis of rotation have a big impact on short-term weather and long-term climate. Milankovitch cycles include the shape of the Earth's orbit, known as eccentricity, the angle the Earth's axis is tilted, known as obliquity, and the change in orientation of the Earth's rotational axis, known as precession. These cycles affect the amount of sunlight and therefore energy that Earth absorbs from the sun. Eccentricity measures how much the shape of the Earth's orbit departs from a perfect circle, thus affecting the distance between the Earth and the sun. Currently, the Earth's eccentricity is near its most circular and is very slowly decreasing in a cycle that spans about 100,000 years. Obliquity, or the Earth's tilt, is why we have seasons. The greater tilt angle, the more extreme our seasons are, as each hemisphere receives more solar radiation during its summer when the hemisphere is tilted toward the sun, and less during winter when it is tilted away. Earth's axis is currently tilted 23.4 degrees, or about halfway between its extremes, and this angle is very slowly decreasing in a cycle that spans about 40,000 years. Lastly, you can imagine axial precession as the Earth rotating like a slightly off-center spinning toy top. Changes in axial precession increase the seasonal contrast in one hemisphere and decrease in the other. In about 13,000 years, axial precession will cause the northern hemisphere to see more extremes in solar radiation and cause the southern hemisphere to experience more moderate seasonal variations. Milankovitch cycles operate on long timescales and provide a strong framework for understanding long-term changes in Earth's climate, but they cannot account for the current period of rapid warming Earth is experiencing. The surface of the sun is a very busy place. The sun's gases are constantly moving, which tangles and twists magnetic fields, thus creating solar activity. The sun takes approximately 11 years to complete one solar cycle. During each cycle, the sun undergoes various changes in its activity and appearance. Levels of solar radiation can go up or down as the amount of material the sun injects into the space. These changes have a variety of effects in space, in the Earth's atmosphere, and on Earth's surface. On the graph, we can compare the global surface temperature change, which is the red thick line, and the sun's energy that Earth receives, the yellow thick line. The amount of solar energy that Earth receives has followed the sun's natural 11-year cycle of small ups and downs with no net increase since the 1950s. Over the same period, global temperature has steadily increased. It is therefore extremely unlikely that the sun has caused the observed global warming trend over the past half century. The IPCC claims that the human burning of fossil fuels are in fact 50 times greater than that slight extra warming coming from the sun. With that being said, let's dive into some of the human-induced causes of climate change. The greenhouse gases most responsible for trapping heat in the atmosphere are carbon dioxide, methane, nitrous oxide, and fluorinated gases. Each gas's impact on climate depends on three main factors. One, how much is in the atmosphere. This refers to the concentration or amount of a particular gas in the air. Larger emissions of greenhouse gases lead to higher concentrations in the atmosphere. Greenhouse gas concentrations are measured in parts per billion, and even parts per trillion. For reference, 1 part per million is equivalent to 1 drop of water diluted in about 13 gallons of liquid. 2. How long do they stay in the atmosphere? Each of these gases can remain in the atmosphere for different amounts of time, ranging from a few years to thousands of years. All these gases remain in the atmosphere long enough to become well mixed, meaning that the amount that is measured in the atmosphere is roughly the same all over the world, regardless of the source of the emissions. Third, how strongly do they impact the atmosphere? Some gases are more effective than others at trapping heat and making the planet warmer. For each greenhouse gas, a global warming potential is calculated to reflect how long it remains in the atmosphere on average and how strongly it absorbs energy. Gases with a higher global warming potential absorb more energy and thus contribute more to global warming. Global warming potential is specifically a measure of how much energy the emissions of 1 ton of gas will absorb over a given period of time, usually 100 years, relative to that of carbon dioxide. So one way to imagine and understand the impact of greenhouse gases in the atmosphere is bioaccumulation and endocrine disruptors. Bioaccumulation is the buildup of chemicals inside of living organisms over time. In the first example, greenhouse gases represent the yellow toxins that eventually accumulate in fish of an ecosystem, which embodies our atmosphere. Over time, toxins become more concentrated and permeous. Similarly, greenhouse gases stay in the atmosphere for tens to hundreds of years after being released, and their warming effects on the climate persist over a long time, affecting current and future generations. Another way of imagining greenhouse gases is the human body and endocrine disruptors. Endocrine disruptors are chemicals that mimic the body's hormones and confuse our physiological systems, which eventually cause adverse health outcomes. Greenhouse gases are ultimately substances that disrupt our natural climate systems. Carbon dioxide or CO2 emissions can be attributed to transportation, electricity, and industry. The combustion of fossil fuels to generate gasoline and diesel to transport people and goods was the largest source of CO2 emissions in 2018. This includes highway and passenger vehicles, air travel, and rail. Electricity is a significant source of energy in the United States and is used to power homes, businesses, and industry. In 2018, the combustion of fossil fuels to generate electricity was the second largest source of CO2 emissions. The types of fossil fuels used to generate electricity emit different amounts of CO2. Burning coal will produce more CO2 than natural gas or oil. Atmospheric CO2 is part of the global carbon cycle, and therefore its fate is a complex function of geochemical and biological processes. Some of the excess carbon dioxide will be absorbed quickly, but some will remain in the atmosphere for thousands of years. CO2, by definition, has a global warming potential of 1, regardless of the time period being used, because it is the gas being used as a reference. In 2019, CO2 accounted for about 80% of all U.S. greenhouse gas emissions from human activities. Methane or stage 4 emissions can be attributed to agricultural energy as well as residential and commercial waste. Domestic livestock, such as cattle, swine, and sheep, produce methane as part of their normal digestive process. Methane is also produced when animal manure is stored or managed in lagoons or holding tanks. Because humans raise these animals for food and other products, these emissions are considered anthropogenic. When livestock and manure emissions are combined, the agricultural sector is the largest source of methane emissions in the United States. Natural gas and petroleum systems are the second largest source of methane emissions. Methane is a primary component of natural gas and is thus emitted to the atmosphere during the production, processing, storage, transmission, and distribution of natural gas, and the production, refinement, transportation, and storage of crude oil. Landfills are the third largest source of methane. Methane is emitted in landfills as waste decomposes and in the treatment of wastewater. Methane emitted today lasts about a decade on average, which is much less time than carbon dioxide, but methane absorbs much more energy than CO2. Methane is estimated to have a global warming potential of 28 to 36 over 100 years. In 2019, methane accounted for about 10% of all U.S. greenhouse gas emissions from human activities. Nitrous oxide, or N2O, emissions can be attributed to agricultural, food combustion, and industry. Nitrous oxide can result from various soil management activities, such as the application of synthetic fertilizers, cropping practices, and the burning of agricultural residues. Nitrous oxide is also emitted when fossil fuels are burned. The amount of nitrous oxide emitted from burning fuels depends on the type of fuel and combustion technology, maintenance, and operating practices. Nitrous oxide emitted today remains in the atmosphere for more than 100 years on average and has a global warming potential of 265 to 298 times that of CO2. In 2019, nitrous oxide accounted for about 7% of all U.S. greenhouse gas emissions from human activities. Unlike many greenhouse gases, fluorinated gases have no natural sources and only come from anthropogenic activities. There are four main categories of fluorinated gases: hydrofluorocarbons, perfluorocarbons, sulfur hexafluorides, and nitrogen trifluorides. Hydrofluorocarbons are used as refrigerants in air conditioning systems in both vehicles and buildings, aerosol propellants, and fire retardants. These chemicals were developed as a replacement for chlorofluorocarbons and hydrochlorofluorocarbons because they do not deplete the stratospheric ozone layer, which protects us from harmful radiation from the sun. Fluorinated gases are sometimes called high global warming potential gases because, for a given amount of mass, they trap substantially more heat than CO2. The global warming potential for these gases can be in the thousands or tens of thousands. Overall, fluorinated gas emissions in the United States have increased by about 86% between 1990 and 2019. Okay, I'll pause here for a moment to let that info sink in and also address any questions anyone may have from the material covered so far, or if anyone would like to ask a question now. And I'll try to catch my breath and drink water. I know it's a lot of information.
And if you do have a question, please, you can enter it in the chat, and then we'll collect it there.
So if there are no questions, we can move along. The warming climate triggers nature's own warming mechanisms, or climate feedback loops. A positive feedback loop enhances or amplifies the effects of change, producing instability. A negative feedback loop reduces or dampens the effects of change, helping maintain balance. So a bit counterintuitive here, but the main takeaway is that a positive feedback loop will increase the effects of warming. Global forests absorb approximately 25% of human-caused carbon from the atmosphere. However, this percentage is shrinking as the climate warms from increased carbon dioxide emissions. Combined with human activity, this warming has resulted in increases in fires, diseases, and insect populations, all leading to tree dieback. As trees burn and decay, they release carbon back into the atmosphere, and with fewer trees left, more carbon dioxide remains in the atmosphere. Both lead to further warming and more tree dieback. If forests release more carbon than they store, they switch from carbon sinks to carbon sources. Permafrost, an icy expanse of frozen ground covering 1/4 of the northern hemisphere, is thawing. As it does, microscopic animals are waking up and feeding on the previously frozen carbon stored in plant and animal remains, releasing heat-trapping gases as a byproduct. These gases warm the atmosphere further, melting more permafrost in a dangerous feedback loop. With permafrost containing twice as much carbon as the atmosphere, its thaw could release 150 billion tons of carbon by the end of the century. A warmer atmosphere absorbs more water vapor, a naturally occurring gas formed by the evaporation of water, mostly from lakes and oceans. It is the most abundant heat-trapping gas, accounting for 60% of all warming caused by atmospheric greenhouse gases. With both the climates and the oceans warming, increasing evaporation adds even more water vapor to the atmosphere. Some water vapor also cools and condenses, forming clouds. By reflecting sunlight away from the planet, clouds can cool the earth, and by trapping heat below them, they can warm it. As the climate warms, oceans are also warming. Although not a feedback loop, the combination of increased water vapor and ocean warming is driving hurricanes, making the stronger storms more frequent. Climate change is also disrupting the jet stream, a west to east flow of wind that encircles the northern hemisphere and is responsible for insulating the weather in North America, Europe, and Asia. When the Arctic is cold, the jet stream wind blows strong and fast. But with Arctic warming at 2 to 3 times the rate as the rest of the globe, the jet stream has weakened, resulting in larger north to south swings. The larger swings of the weakened jet stream result in extreme weather events, as weather stalls in one place for a long time. Because of this, the wet places become more damp and the dry places become warmer and drier. The multi-year drought in the western US, the increase in wildfires, and the extreme heat in the Pacific Northwest in 2021 are connected to this larger north to south swing in the jet stream. The reflectivity of snow and ice at the poles, known as the albedo effect, is one of the Earth's most important cooling mechanisms. At Earth's poles, snow and ice reflect up to 85% of the sun's rays away from the surface and back into space, helping to keep the planet cool. In the Arctic, this natural mirror has begun to break down as warmer temperatures melt snow and ice cover, reducing the planet's reflectivity. In summer, when the ocean snow melts, the open water absorbs 90% of the sunlight, warming the ocean, which in turn melts more sea ice, reducing reflectivity even more. Approximately 25% of global warming can be attributed to the loss of Arctic sea ice. In Antarctica, the melting of land ice at the South Pole doesn't affect reflectivity because the ice sheets are miles thick. However, as ice melts and enters the ocean, it causes sea level to rise. If both Greenland and Antarctica's glacial ice shelves were to melt, sea levels could potentially rise by more than 100 feet. We briefly touched on some of the impacts of climate change just now through examining feedback loops, but let's officially delve into climate change indicators. Climate change indicators are observations or calculations that land managers, scientists, and planners can use to track conditions and trends. They can also be used to understand how environmental conditions are changing and inform resilience planning. Greenhouse gases from human activities are the most significant driver of observed climate change since the mid-20th century. The graph on the top right corner shows that the warming influence of long-lived greenhouse gases in the atmosphere has increased by 47% between 1990 and 2020. Rising global average temperature is also associated with widespread changes in weather patterns and considered the main driver for many other climate effects. Heat waves are occurring more than they used to in major cities across the US, and over the period from 2000 through 2020, roughly 20 to 70% of the US land area experienced conditions that are at least abnormally dry at any given time. The figure on the center shows how annual average temperature worldwide has changed since 1901. Climate change can fundamentally alter many properties of the ocean. The amount heat stored in the ocean has substantially increased since the 1950s, and sea surface temperature has been consistently higher during the past 3 decades than at any other time. The ocean has also become more acidic because of increased levels of atmospheric CO2, which dissolves in the water. Higher acidity affects the balance of minerals in the water, which can make it more difficult for certain marine animals. Coral reef structures, for example, are affected by the rising temperatures and CO2 concentrations in the ocean. As we touched in our feedback loops, the amount of water stored in snow and ice and the timing of freezing and thawing cycles have changed dramatically over the past century in many parts of the world. Total snowfall, total snowfall has decreased in most parts of the country since widespread records began in 1930. One reason for this decline is that nearly 8% of locations studied have seen more winter precipitation fall in the form of rain instead of snow. Glaciers in the United States and around the world have generally shrunk since the 1960s, and the rate at which glaciers are melting has accelerated over the last decade. The loss of sea ice from glaciers has also contributed to the observed rise in sea level. Declining sea ice also threatens natural habitats for animals like polar bears and walruses, and affects people living in the Arctic who rely on ice for hunting and subsistence. Changes in the Earth's climate can affect public health, agriculture, water supplies, energy production use, land use and development, and recreation. The nature and extent of these effects and whether they'll be harmful or beneficial will vary regionally and over time. Lastly, changes in the Earth's climate can affect ecosystems by altering the water cycle, habitats, animal behavior, and the timing of natural processes. While plants and animals have adapted to environmental change for millions of years, the climate changes being experienced now could require adaptation on a larger and faster timescales, thus increasing the risk for extinction or severe disruption of many species. While wildfires occur naturally, more frequent and more intense fires can significantly disrupt ecosystems, damage property, put people and communities at risk, and create air pollution problems even far away from the source. So we all rely on land, air, and water for our health and well-being. Climate change, however, can exacerbate existing health threats or create new public health challenges through a variety of pathways. Figure 1 here shows how climate change can affect people by changing their exposure to health threats. For example, the climate impact of increased temperature leads to exposure of extreme heat, which results in a health outcome of heat-related illnesses. Environmental, institutional, social, and behavioral factors such as geography, age, and gender may influence or affect the health outcome. Next slide, please. Figure 2 shows 3 examples how climate impacts can affect health. The number circles identify where climate change indicators provide key information at different points along the pathway. For example, the flooding pathway shows how indicators of certain climate impacts like sea level, heavy precipitation, and coastal flooding could be used by state and local health officials to better understand the changes in human exposure to contaminated waters, a health risk. By recognizing changing risks, these officials can better understand how climate change affects the number of people who get sick with gastrointestinal illness, a health outcome. Thus, even where health data or long-term records are unavailable, or where the links between climate and health outcomes are complex, indicators play an important role in understanding climate-related health impacts. So who's at risk? Every American faces a risk of health impacts associated with climate change. Some people, however, face higher risk than others because of the differences in the hazards to which they are exposed, their sensitivity to these hazards, and their ability to adapt. Thus, it is important to be able to identify populations of concern, which include groups representing people of all ages living in different places who interact with the environment in different ways. Figure 4 here shows some examples of how certain populations are more vulnerable to health impacts because of differences in their exposure, sensitivity, or ability to adapt to climate-related stresses. It's important to remember that the different health impacts identified here do not occur in isolation. People can face multiple threats at the same time, at different stages in their lives, or accumulating over the course of their lives. Risk may increase as people exposed to multiple health risks. For example, extremely hot days can lead to heat-related illnesses, as well as poor air quality by increasing the chemical reactions that produce smog. In addition, many of the factors that influence whether a person is exposed to health threats or whether they become ill, such as an individual's personal habits, living conditions, or in access to medical care, can also change over time. Certainly, we're in the face of a climate emergency, and we need global climate action now. But what does that exactly entail? Climate policy must incorporate mitigation efforts such as reducing emissions and enhancing the sinks of greenhouse gases, as well as adaptation strategies from various approaches that prepare us for expected climate and its effects. Ultimately, building climate resilience, the ability to cope with a hazardous event and maintain essential structure, will require all actors, governments, communities, businesses, and individuals. Healing the planet can begin in our daily lives with simple choices. Greening our travel by carpooling or taking public transit reduces carbon dioxide emissions. By planting and protecting trees in natural areas, we preserve carbon sinks. Shopping and cooking efficiently prevents food waste from reaching landfills and eventually emitting methane. In September 2016, Governor Edmund Brown Jr. set methane emission reduction targets for California and SB 1383, a statewide effort to reduce emissions of short-lived climate pollutants through organic waste recycling and surplus food recovery. Methane emissions can also be curbed by choosing reusable, long-lasting items as well as, of course, recycling. Cutting energy use and switching to solar in our homes decreases the demand for fossil fuels. Last but certainly not least, we can all speak up and inform others about the information discussed today. One form of cutting organic waste is composting. Composting diverts organic materials from landfills into a soil amendment that helps increase resiliency among climate change impacts such as drought and extreme weather through carbon storage and reduction of synthetic fertilizers. The Riverside County Department of Waste Resources offers free educational classes on composting and vermicomposting throughout the year in our resource garden and offers home composting bins for purchase. Recycling is also an extremely easy and impactful way to combat climate change in your home. Recycling eliminates the need for new raw materials to make new products. For instance, recycling 1 ton of paper saves 17 trees from being cut and also reduces energy and water consumption by 40 and 30% respectively. So let's set the record straight by debunking some climate change myths before we conclude today's class. 1. I have never been affected by climate change. As we establish, climate impacts are affecting communities around the world by changing their exposure to health threats like extreme heat and poor air quality. As the climate crisis worsens, we can only expect increased health risks. 2. Climate change will happen in 50 years. The indications of climate change have been observed and recorded since the mid 20th century. Greenhouse gases will likely exacerbate climate change in upcoming years if we don't curb our emissions now. 3. Climate change does not occur in the United States. The U.S. is no stranger to climate change. Parts of the U.S. are experiencing abnormally dry conditions, increased wildfires, and melting of ice glaciers. I'll close off our introduction to climate change class by directing you all to some valuable resources. The County of Riverside's Climate Action Plan was approved on December 2019 and refines the county's efforts to meet greenhouse gas reduction targets, specifically for the years 2035 and 2050. 350 Riverside is a county-wide volunteer group of grassroots climate activists who work to keep fossil fuels in the ground, limit emissions, improve air quality, and build a clean, equitable, zero-carbon economy. Lastly, U.S. Climate Resilience Toolkit is a website designed to help people find and use tools, information, and subject matter expertise to build climate resilience. The toolkit offers information from all across the U.S. federal government in one easy-to-use location. Thank you so much, everyone. I hope you were all able to learn something new throughout this class, and I'll address any questions we may have in the chat, or if anyone wants to ask a question now, more than happy to clarify and expand on anything. And then please stay connected and follow us on our social media platforms, visit our website, and reach out. Thank you.
Thank you. Thank you, Lizette. We do have a question and a comment from Pat, and it's we can't control or change Earth's orbit or tilt, right?
No, that they're still powerful. um, yeah, upon my research, I didn't discover anything um, human activities may influence Earth's orbit and rotation, but because a lot of this climate change crisis information is ongoing, right? There may be a potential down the road where, our activities and actions today can eventually impact the Earth's orbit and rotation, but I didn't discover any information on that upon my research, but yeah, that's a good question.
And then we have a comment from Des, who wanted to say thank you for providing this education. I've been driving and running errands while listening, so I can't interact much.
Thank you, Des, for joining in. I really appreciate that, and I hope, yeah, I know it was a lot of information, but and I unfortunately can't cover everything. There's so many different areas to this, but I hope, we're able to understand the causes of climate change and what we can ultimately do to combat that. So thank you.
And then we do have another question from Tiffany, and is it better to buy something online rather than driving around town to do shopping?
That's a tricky question, and I'll have a cop-out answer, and I'll say, um, shop locally, because online shopping, right, we have to think about the process of buying something online, right? That item can travel up to like 100 miles to even get to your home. Um, right, those big diesel trucks are probably contributing to that transportation process and ultimately emitting more carbon into the air, right? Um, but driving around your town locally will, compared to that diesel truck, um, is substantially less. So individual local actions, I think, are the best way.
And then Des did have another question: is will a recording be available for review?
Yes, I think we were recording, correct?
Yes.
Yes.
And
Yeah, I think it should be up on our YouTube page and website in about a week or so. So yeah, be on the lookout for that.
so Tiffany has a comment. Thank you so much, Lizette. That was awesome.
Thank you so much, Tiffany, for joining.
And those are all the comments I have.
Okay. Yes, of
Oh,
course.
wait,
Thank
sorry.
you.
One more. Debbie Louie says a lot of information. Thanks for presenting this.
Yes, thank you for joining, Deborah.
So those are all the questions. So we'll do the recording and then have that uploaded on our website.
Okay. Yes, happy Earth Week. Thank you so much, everyone, for joining. Wish you all a nice week and yeah, happy Earth Day.